data or to write data to the main memory or from the memory, from an input device or to an output device. For the input-output operation to be completed, the process will be waiting. It won't be executing or running. And when the process finishes executing, it will be terminated. As we can see in this diagram, the process can change its state from one state to another state and back to the older state. The process starts as new, loaded into the memory. After given the resources it needs to be executed, it will be admitted and it will be a ready process waiting for the CPU to run. When the process is granted the right to enter the CPU, it will be a running process. As we will see in a short while, this decision to give a ready process the right to be executed is taken by a scheduler or a scheduler. A running process will either finish executing and it will be terminated, it will exit and be terminated, or it will be waiting for an input-output event. So it won't be running anymore and it will be waiting. Upon the completion of the input-output command or event, the process will be again ready. Sometimes a running process can be forced out of the CPU using an interrupt for various reasons. Maybe a process with higher priority, with higher importance, is now ready and it needs to be executed. Or maybe the scheduler uses time slice, where it gives each process certain amount of time to run. If it actually finished its job, it's fine. If not, it would be forced out and another process will replace it in the CPU. How scheduler work? How schedulers, actually there are multiple schedulers, how the schedulers work, that will be discussed in a later chapter. So again, a process is new, loaded into the memory. When it's given all the resources it needs to be executing, it will be a ready process and it will be waiting for its turn to use the CPU. Granted the right to be executing, it will be a running process. A running process can either finish its execution, then it will exit and be a terminated process, or it will need an input-output operation, then it will be a waiting process, or it will be forced out of the CPU using an interrupt. In this case, it will be a ready process because it's waiting for nothing. It will be a ready process. A waiting process upon the completion of the input-output event will again be a ready process. If the process can be swapped out of the CPU in case of it's waiting for another for an input-output operation, or it was forced out of the CPU for any reason, such as a process of higher priority is now ready to run, or the time slice that was given to her has finished without the process finishing execution. There should be somehow to keep track of the current state of the process when it's taken out of the CPU and when again it resumes executing on the CPU. Because if there is no means of saving the state of the process, that means each time the process leaves the CPU, it will start running from the beginning. This created the need for a record of a kind, a struct that is called a process control block, a PCB. So a process control block is a data structure that contains the important information the process needs to restart, to resume execution on the CPU. Basically, it will tell what state the process is, the process ID, the program counter, the registers, the values are in the registers, the memory limits, the list of open files. The process state, is this process running? Is it waiting? Is it ready? Has it terminated already? The process ID, the process number, is the identifier of the process, of course. And the program counter that will tell at which point exactly the execution of this process has reached. The registers are actually the values of the CPU registers where the process stores its variable values while executing. While actual execution, the variable values are stored in the CPU registers, not in the memory. Then the memory limits, that's to tell which part of the memory belongs to this process. And if the process is using files, there will be the list of open files this process is reading from or is writing to. If this process is using input-output devices, this also will be listed. If the process has priority, has certain time limits, everything that has to do with the process and that is needed for the process to be executed will be in the process control block. Why do we need it? Let's have a look. In a multi-programming environment, and that's to say, multiple processes coexist in the main memory at the same time and take turns in using the CPU. In the current example, we have two processes, process 0 and process 1. So process 0 was executing, then it was interrupted by a system call. It will be swapped out of the CPU. Before this happens, all the information of process 0 has to be saved in process 0 process control block. Then process 1, and this time process 1 will be idle. Then the process control block of process 1 will be reloaded into the CPU, so it can resume running from the spot that it has stopped in the last time, and it will start executing. Then it will be interrupted by the operating system, and before it leaves the CPU, all the information has to do with process 1 has to be saved in process 1 process control block. Then process 0 process control block will be loaded, so it will start executing from the point it has stopped. If you can see, there is a wasted time between when process 0 stopped executing and when process 1 started executing. And again, between when process 1 stopped executing and when process 0 started executing. This wasted time, where process control blocks are saved and loaded, is actually called context switching time. And I have to find it. It's called context switching time, where context switching time is the time that the CPU needs to save the state of the older process and to load the state of the new process. This is an overhead, a wasted time, but it is actually a must. Process control, the context switch time has to be taken into consideration while designing any scheduling algorithm for the CPU, because we need to minimize number of context switches to minimize the overhead. And I hope you will keep this in your mind until we actually discuss scheduling.